Hello and welcome to another C++ tutorial. So this time we're going to be taking a look at the concepts of pointers and references and the different ways of passing information around. So these are something that they do exist within C#, and we do have a measure of control over them, but it's largely sort of hidden from us. And although it's actually really important to understand how they work in something like C# as well, we don't have a lot of visibility to it. But C++ we do, so we're going to take a look at these different concepts and understand how they actually work. So let's dive on in. So to begin with, I'm going to need a function. So I'm going to create simple function, and we'll give it this input value, and what it's going to do is it's going to return input value, and it will also add 10 to it. So what I want to do here is input equals 5. I want to then be able to do output is equal to simple function with input, and then I want to output here. Input is now, and then the value. And we'll do the exact same thing with output. So before I run the code, I want you to have a look at what's happening with the code. So we've created a variable called input. We've given it a value of 5. We are then running simple function and providing that variable, which it comes in here, and our parameter is called input value, which it uses a plus equals, so an add and update of 10 on it, and it returns that value. So looking at this, I think it's quite clear we can figure out that, yep, what we get for output should absolutely be 15. But depending upon how this gets handled, our input here could be 5 or it could be 15. And this is something that's really important to understand. So we're going to run this and we'll see what happens. So we can see input is now 5, so it hasn't changed, and the output is 15. So what is happening here is input is passing by value. When we pass by value, we are creating a copy. So input value is pass by value. The function gets a copy of the variable, or copy of the input. So we're getting a copy of it. So whatever we change with that only exists within this function. So going and making any changes we want to this won't make any difference to what we passed in, because we never actually got that original thing. So the way to view it is we've got a piece of card. That card has 5 written on it. That's our input. Simple function, we haven't gone and handed that paper over to it. It doesn't actually have that bit of card. What we've done is we've held it up, and then that function has written down on its own piece of paper 5. So it's created a copy of it. So that's called passing by value. And there's nothing here that we can see that immediately tells us that it's passing by value, and that's because pass by value happens when we don't indicate anything extra. Pass by value is the default. Now we have another way of passing things, which is by reference. So we're going to have simple function 2, and I'm going to put int ampersand input value. And then I'm going to do the exact same logic. So then what I'm going to do, so first I'm going to put these on their own separate lines so that we can easily just run this and do the exact same test multiple times. So output like that. So this is running simple function 1. Then, and I'll actually rename this. So that's 1, and this will be 2. So let's have a look now and see what happens. So first set of input and outputs we see will be for simple function 1. The second set will be for 2. So we run these, and we can see the behavior for simple function 2 is different. It actually did modify the input. So this second case, what we would say is input value is pass by reference. The function gets a reference to the input. That's what this ampersand is doing here. It's saying that this parameter isn't an integer. It is a reference to an integer. So a reference, what that is a piece of paper that what it has on it isn't the value, it's where to find the value. So, whereas our first case here of passing by value, our piece of paper says on it 5. In this second case, our piece of paper says you can find the actual piece of paper at this location. And as a result of that, it's able to modify it. Now these two versions, pass by value and pass by reference, they exist in C#. So they exist in things like of Unity. But whether something passes by value and reference is actually based on its type by default in C#. So in C++, we have explicit control for everything. In C#, something that is a class, so a mono behavior if you're in Unity, things like a list, dictionary, all of those things pass by reference by default. So classes are always passed by reference. Whereas a integer or a float or a struct pass by value. So they create a copy. So two different ways of working with it. So C#, it's very, it's something where it is important to understand it, because if you are creating a copy, you can imagine if you had a very large amount of data, that's a lot of overhead, partly in the memory usage, but also in the process of creating that copy. So we try and keep it that something that is passing by value is only for things that are quite small in size, and that it's safe to do so. Large data, complex data, we shouldn't be passing by value. So pass by value for simple data, pass by reference for large or complex data, or in particular, large complex data. So that's good. Now, reference is one way of doing this. We actually have a second way of doing this also in C++. So I'm going to create something here, simple function 3. I'm going to do int star input value. And this one, I'm going to have to write it a little bit differently, because we'll see that it has an error. So I need to work with it a little bit differently. But let's see what happens when I go and actually work with it. So simple function 3, and I will explain what the differences are momentarily. I just want to have the stuff implemented so we can see what the behavior is first. So we can see it behaves exactly the same as the reference version. What we are doing here is input value is passed by pointer. So the function gets a pointer to the input. So when you see a variable type and ampersand, that means that it is a reference to something. So variable type ampersand is a variable, or is a reference to a variable of variable type. Whereas down here, variable type asterisk is a pointer. Now, there is a slight difference between a pointer and a reference. In both cases, they tell us where to find a particular thing. So a pointer is going to, just like a reference does, it's a bit of paper that says, here is where this thing actually is. Here's where you can find it. And we're finding it in memory. So in both cases, pointer or reference, they're referring to or pointing to a location in memory. The difference between these two is the process around creating them. So I can create a pointer to anything, and I mean quite literally anything. I could do simple function 3, and I could provide, a particular value in here if I wanted to. As long as I might need to do a couple of little tricks, but I could do something where, okay, 1, 2, 3, 4, 5. So I'm just saying at memory location 1, 2, 3, 4, 5. I could provide a null, so a 0 or invalid location. So a pointer, it says the addresses of where something is located, but it doesn't mean it's actually there. It might have been at one point in time, but it may no longer be there. So a pointer can become invalid. A reference, however, when we create a reference, we have to create it to something that is concrete, that exists. If you try to create a reference to something that doesn't exist, you will actually get an error at that particular point. So that's the big difference between a pointer and a reference. A pointer can be invalid. This here, I can't guarantee that that actually exists. It could be garbage. It could be garbage in a way that I can tell that it is garbage, or it could be garbage in a way that I can't tell that it is, which means I can't tell if it's valid or not, and I go to work with it, and then everything breaks. So we do need to be a little bit more cautious with working with pointers, but it can be really handy to be able to have something that can actually be invalid. It means we get a little bit more information because we have something that can either be a particular thing or it can be nothing, which we can't do with a reference. A reference must exist. So both have their places, and both are quite useful. With pointers, our syntax ends up being a little bit more involved. So to access the value of a pointer, we have to do this. We put an asterisk in front of it. What we're doing is we're dereferencing it. So an asterisk in front of a pointer dereferences. So star pointer variable equals dereference pointer variable, i.e. get the value of it. And down here, we saw I was doing an ampersand and a variable. So ampersand variable equals reference to the variable, i.e. get a pointer to variable. So, and this is something where absolutely pointers are something that's confusing. They really are. And references as well. One of the things that is confusing is the syntax. So it's important to remember these key things. Variable type and then an asterisk or an ampersand means you're creating a pointer or a reference. The name of a variable preceded by an asterisk or an ampersand means you're either dereferencing, so you're getting the value from a pointer, or you are referencing it. You are getting the address of it. You're getting a pointer to that particular thing. So these allow some really nifty tricks, because pointers, as I said, can be null. If I tried to do something where, okay, I want to go simple function 3 and null. So null PTR is null pointer. So when you need to provide a value for a pointer saying that it doesn't exist, that it's invalid, always use null PTR. That's the recommended best practice there. So, and when you need to initialize it, set it to something like of that. So what I could do here then is I could say if, now in C#, for doing a null check, what I have to do is in C#, I have to go and check, well, is it, equal to null PTR in C#, just null. We actually don't need to in C++. In C++, we can just do this. So if I do not an R pointer value here, that will actually detect, is it null? So is the pointer null or null PTR? So I can do a check of if it is null by checking if it is not, and then provide the pointer. If I wanted to check if it is valid, then what I would do is I would go and check just F input value. So you can't do that in C# generally, but in C++ we can. Which means I could return -1, and I could output here null provided to simple function 3. So if I run that, what we'll see is it detects it. So we can do null checks, and that's something where if you're working with pointers, you do want to make sure that you are doing null checks. If you don't, well, let's see what happens. So if I comment all of that out, we get an exception. And what we get is an access violation, because a pointer, it corresponds to a location in memory. So if you try and access a section of memory that you don't own, it will not allow it. And depending upon the operating system, that might actually immediately terminate your program. So it's a lot less risky these days, but that doesn't mean you couldn't still mess up something within your own program. So you could do something where you have a pointer to a variable that you do own that variable. And then you could actually go and adjust some other variable very easily if you had that pointer be incorrect. So it's something that we do need to be a little bit cautious with. So we can actually do some very simple things called pointer maths as well that can be really handy. So say I create an array. So integer array, we'll say that that is 5, and let's give that a bunch of values, 10, 20, 30, 40, 50. So we've got our integer array. Let's create a pointer, array element pointer. Now, something that happens behind the scenes, an integer array is a pointer. Anytime we create a variable that's an array, that's actually a pointer. So this is pointing to the array. So what if I output array element pointer, that, and I'll dereference that. I should get 10 appear, which I do. What if I did this? So I'm just adding to it. Let's see what happens now. Think about what you think might be the output from there. Is it going to be 11? Is it going to be 20? Is it going to be something completely different? Am I going to get a crash? Well, let's find out. So we can see it gets 20. So I can use pointer maths, is what we're referring to here, to move to different elements in the array. So I could actually loop over this array purely using pointer maths. Now, the thing I need to watch for is I need to somehow know whether I'm at the end of the array or not. So I'd either need to have some kind of end marker I look for, or I would need to know the size of that array. But that gives me something where I can, do that sort of iteration over the data, which can be really handy. There are a couple of times where things like that can be super useful. So okay, we've seen what happens. We pass things by value, by reference. We've seen passing things using how we can create those references and pointers. And we've seen a little bit of stuff here with pointer maths, so that's good. What about with diving in a little bit further, seeing a little bit more with references? So say I wanted to create a reference to that. So array element ref, and if I did integer array, and we can see that isn't going to work because a reference needs to correspond to a concrete value. And this is a pointer. We don't have the asterisk there, but because it's an array, it's actually a pointer. So I would have to do that. I'd have to give it that very specific element. So now, if I go and I'm going to output array element ref, and then if I did ++ and output the same thing again, and what I'm also going to do is I'm going to just output this. So we know the reference is linking to it, but just so we can see for certain. So we can see we get 10, which is the correct first value. Then we have added 1 to it. So the new value we output, the value that reference has is 11. And that first element in the array has changed as well. So a reference, once we have linked it to something, it stays linked to that. It's permanently, it's like eventually we've written on the card in ink. Whereas with a pointer, we've written on it in pencil. We can erase it, we can write in a new location on there. So when we're working with references, the main difference is that we're able to be modifying that data we're working on. So pointers, if we do a ++ and update those, that's going to move to the next element, unless I dereferenced it. If I dereferenced that first, then it would be able to be modifying the variable, but in this case, it's not going to. Whereas a reference stays permanently bound. If I tried to do array element ref is integer array 1, for example, that's not going to rebind it to element 1. That's going to take the value of element 1 and store that in element 0. So a reference, once it is set up, we cannot change what it is referring to. That is locked. Whereas a pointer, we can rebind it. And that's why with pointers, we have to have that support for them being able to be null, because they could be bound to anything. So that's pretty good. There's one final way of passing things in that can be really useful, because we might want the advantage of being able to pass something without creating a copy, but we might not want the function to be able to modify it. So what we can do in that case, and I'm going to use this, we'll have simple function for, and we will have const int. So this is passing by what's called a const reference. This is a const reference. It cannot be modified. And we can see it actually gives us an error. It won't compile. So if you have complex data and you want to pass that in efficiently, but you don't want the function to be able to modify it, then we can use a const reference. So we've got a lot of different ways of passing information around. And that can be a bit overwhelming in trying to work out how do you decide which way to pass things. So two main questions that I would be asking yourself when you're trying to work that out. Is the data simple or complex? So simple data is going to be something like an integer or a float, or something that contains only those very simple types of integer, float, boolean. So simple data, or is it complex data? Does it itself contain pointers and references? Then it's automatically complex data. Does it contain vectors or lists or maps? Again, automatically complex data. So simple or complex is an important first question. And then also asking yourself, is it a small amount of data or is it a large amount of data? If we have, and I'll actually write this sort of here, simple data and it's small, I would pass by value if we're not needing to modify it. So you'd pass by value if not needing to modify. Otherwise, typically reference or pointer. So if it's simple data and it's small, then we would do that. If it is complex data, then it actually doesn't matter whether it's small or large. What I would say is we're looking at if it doesn't need to be modified. Doesn't need to be modified. Then we would do pass by const reference. Otherwise, reference or pointer. That's generally what I would say. So you only use pass by value if you're not needing to modify it and it is simple small data. Everything else should be a reference or a pointer, or potentially const reference. Now, in terms of whether you use a reference or a pointer, that depends upon whether there is a chance that it validly could not exist. If it validly could not exist, use a pointer. If it not existing not only should never happen, but is actually considered a significant sort of failure mode if it happened, then I would use a reference. So generally, pointer if there's any chance that it might not exist and it's valid for it to not exist, otherwise a reference. So that's how I would go about choosing which ones you pass in. So simple small data, value if you're not needing to modify, otherwise reference or pointer. And complex data should always be something like a reference or a pointer. If you can, const reference. So always good habit there of if data doesn't need to be modified, then make it const in the parameters so that not only are you clearly signaling that it doesn't need to be modified, but if you accidentally write code that tries to modify it, you'll get an error, which is really handy. It allows us to make our code a little bit more safer and allows us to avoid potential unintended changing of data, which is really important. So dive on in and experiment with this. Set up some functions yourself. Try different ways of passing the inputs in and experiment and see what happens when you do different combinations of passing something in and modifying it, doing different things with pointers. Experiment with the stuff. Some of the things might break, and that's okay. It's a good opportunity to see how it breaks, because these are things that will break when we're doing further development, and that's okay. We get to see how they break. so that we can practice and learn how to fix them, because that's going to be a big part of the job, is doing that. So getting that familiarity early on is really useful. So experiment with it, see further things that you could do with pointer maths. I mentioned that we could be using that for iterating over an array. So have a go at setting that up, setting up a for loop that does iterate over an array only using pointer maths. Try it with different types, see how that works as well. But just the key is experimenting with the different things you can be doing there. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you had any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. There is a link to that in the description below. And you can use that code in any of your own projects, commercial or non-commercial ones. If you are looking for trying to find other videos on similar topics that I've done, I do have a searchable video archive, which I've got a link for that in the description also. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below. But until next time, bye.